This is quadratic roots or quadratic formula. This is quadratic. We want to prove from the general quadratic form how we can obtain the quadratic roots or the quadratic formula. So we begin from the problem. The given problem is the quadratic equation. Ax squared plus bx plus c equals to 0. That is the general form of a quadratic equation. You want to prove that x equals to minus b plus or minus root of b squared minus 4a squared over 2a, which is referred to as the roots of a quadratic equation or the quadratic formula. So the first thing that we are going to do is to divide through this quadratic equation by the coefficient of x squared, which is a. So we begin. Divide through by a, and we are going to have ax squared over a plus bx over a plus c over a equals to 0 over a. Our next step, we simplify. We know a and a is gone. We will have x squared plus b over a of x plus c over a equals to 0, because 0 over a is 0. Then we transpose the constant term. This is referred to as the constant term of the quadratic equation to the right hand side. Definitely we will have x squared plus b over a x equals to minus c over a. That is so because it was positive to this other side will become negative, and we call that equation 1. This approach is called completing the square method of solving a quadratic equation. So this approach, we will pause at this point and complete the square on both sides of the equation. So we begin by saying coefficient of x in this equation 1 as b over a. Then half of that result, the result was b over a. So half of b over a will definitely give us b over 2a. Then thirdly, the square the result, square of b over 2a, which will be b squared over 4a squared. Then at this juncture, we add the result. Add the result, which is b squared over 4a squared, b squared over 4a squared, to both sides of equation 1. Both sides of equation 1. We have to add both sides of equation 1. B squared over 4s squared to both sides of equation 1. So go back to equation 1 and copy x squared plus b over ax. To the left, that is to the left, we add b squared over 4a squared. Then go to the right, minus c over a, we add b squared over 4a squared. We have completed square of both sides at this juncture. So we begin by saying we factorize the left hand side. Factorize the left hand side. And simplify the right hand side. And simplify the RHS, right hand side. So let's see. Here we will not go, we are going to look at economic way of factorizing this. We will not waste time to do the proper factorizing, the short way of factorizing this. Out of x squared, we pick x and keep. We move back to half of the coefficient of x that gave us b over 2a, and it was positive, plus b over 2a. And enclose it in a bracket, square it. This is the complete factorization of this without waste of time. I repeat, out of x squared, we pick one of the x and keep. go to half of the coefficient result of x that gave us b over 2a and it was positive. We included square it. That gives the factorization of the left hand side. Then we approach the right hand side. Start with the positive b squared over 4a squared minus c over a. At this juncture, we find LCM of 4a squared and a, which definitely is 4a squared. We divide this by this, which gives us 1. 1 times b squared is b squared. Maintain the sign minus 4a squared over a will give us 4a times c. We have 4ac. So, of course, we will have x plus b over 2a all squared will give us b squared minus 4ac over 4a squared. To remove this square, at this point, we can take the square root of both sides. Take the square root of both sides. Square root of the length of x plus b over 2a all squared will become plus and minus square root on the right. B squared minus 4ac over 4a squared. So at this point, the square and the square root will vanish, leaving you with x plus b over 2a equals to plus and minus. The numerator here cannot be simplified in terms of square root, so we will keep with the square root sign, b squared minus 4ac all over square root of 4a squared will give you 2a. And at this point, we can transpose b over 2a to the right hand side. So the root, which is in terms of x, will be x equals to minus b over 2a plus and minus root of b squared minus 4ac over 2a. The root in the partial form is x equals to minus b over 2a plus and minus root of b squared minus 4ac over 2a. It's in the partial form because these are partial fractions. So we want to bring it to a single fraction. The denominators are the same. We marry it together and have a single fraction, or what we call a compound fraction. So we are going to have x equals to, the denominator are the same, we add the numerator. So we will have minus b plus and minus root of b squared minus 4ac all over 2a. This is called the roots of quadratic equation, or what we now call the quadratic formula for finding the roots of quadratic equation. Of course, this is this will be will make up of two roots, two answers for the quadratic equation. We are going to split it. The first root, we call the first root alpha. We call the second root beta. So let's see the first root as we call alpha. Alpha and beta are the roots of quadratic equation. So alpha, which is the first root, will be given as minus b plus root of what? B squared minus 4ac all over 2a. That is alpha. Then the beta, which is the second root of the quadratic equation, will be written as beta equals to minus b minus root of b squared minus 4ac all over 2a. So we can see that the roots are in two forms. We call that roots of quadratic equation. Roots of quadratic equation. Those are the two roots of quadratic equation. What we have inside the root number here, or what root symbol, the root symbol here, the root symbol here. What we have inside there is called the radical. This is called the radical symbol. So what is inside the root symbol is called the radical. We can call the radical a discriminant or an operator. So the discriminant, which is the operator, is given as b squared minus 4ac. So likewise, we can say alpha will become minus b plus root of the discriminant, the operator. over 2a. Or beta will be equals to minus b minus root of the discriminant, still over 2a. From here we can check to see and prove that also that alpha plus beta will be equals to minus b over a. And the product of the root, which is alpha beta, will be given as c over a. In our subsequent studies, we are going to prove this using the two roots of the quadratic equation. Thank you very much. Have a nice day.